Good morning, everybody. This is the third lecture for our class, Stars and Galaxies. In this class, we'll be talking about a star, sun. Why does the sun shine? What are the basic properties of the sun? And then we'll talk about the two very important concepts in astronomy, which is luminosity and the apparent brightness. How do you calculate the apparent brightness? As all of we know that the sun is a star. It is a giant ball of hot gas which generates light, and it shines brightly in all directions. It radiates energy in all directions. But the question comes, why does the sun shine? What is the source of energy that makes sun shine? In next couple of slides, we'll talk about the source of energy which makes the sun shine. The ancient thinkers often thought that the sun is on fire. They thought that there must be some wood or coal or chemical sources which makes the sun shine, which makes burn the coal or wood, and it's radiating the energy which is the source of energy for the sun. Well, at the time it was a very well approximation to understand the source of energy for the sun, because at the time they had no idea the distance between the sun and the earth and how incredible its energy output is, and they had no idea how long the earth existed. So at the time, assuming that the sun is burning due to coal or wood was a fairly okay estimate. So if the sun were burning on fire due to its chemical energy, wood or coal, then it would have been lasted only about 10,000 years. But the sun had been shining for more than 4 billion years. So there is no way that the chemical energy would support the shining of the earth for about 4 billion years due to its chemical energy. What does it tell you? There must be some other source for energy which makes the sun shine. So the chemical energy is not sufficient enough to support the shining of the sun. So there must be something else. The other hypothesis, in the late 19th century, astronomers came up with the idea that the sun generates energy by slowly contracting in size, that we call the gravitational contraction. Well, if you think a shrinking gas, if you have gas and if you reduce in the size, the shrinking gas heats up because the gravitational potential energy of gas particles which are far from the cloud is converted into the thermal energy. So a gradual shrinking sun would always have some gas moving inward and which converts into the thermal energy. What I'm trying to say is if the sun contracts, then this gravitational potential energy converts into the thermal energy, and that thermal energy would have kept the sun hot. Then the scientists started doing the calculation, and the calculation showed that if due to the gravitational contraction, the sun would be shining steadily for only about 25 million years. If you know the diameter of the sun, and if you do the gravitational contraction, then the sun can support or would shine only for about 25 million years. For a while, some astronomers thought this idea had solved the ancient mystery of how the sun shines, but the geologists pointed out, by studying the rocks and fossils, they found out that the rock and fossils on the Earth's surface is more than 25 million years old. So if you have the rock and the minerals which are more than 25 million years, that means the gravitational attraction would not be the mechanism by which the sun generates energy. So neither the chemical reaction nor the gravitational attraction could explain why does the sun shine. If you take the gravitational attraction, it by this mechanism it can generate energy for only 25 million years, but the earth is more than 25 million years old, and without sun, as we know, that life would not be possible on the earth's surface. So there must be some other mechanism, and we'll talk in a minute. So the other mechanism that supports the shining of the sun is called, by process called the nuclear fusion or nuclear energy, and it is by one of the greatest scientists, by Einstein's. It was the Einstein's formula, E equals to mc square, or the nuclear fusion. So I'll explain in next couple of slides what is nuclear fusion. So when both the chemical process and the gravitational contraction would not support the hypothesis, why does the sun shine? The Einstein's theory, his famous theory of E equals to mc square, showed that the sun mass contained more than enough energy to account for billions of years of sunshine. If the sun could convert the energy of mass into thermal energy, it could shine for billions of years, and this is by the Einstein's famous formula E equals to mc square. And the process by which it generates its energy is the nuclear fusion. The nuclear fusion is a process in which the atomic nuclei of low atomic number combines to form a heavier nucleus, and when they combine during that process, it releases huge amount of energy. and that is the source of energy in the sun. So remember, the, the source of energy, or in other words, we say that the sun generates its energy today is because of the nuclear fusion process. The nuclear fusion is a process in which the atomic nuclei with low atomic number combine to form a heavier nucleus. And during that process, it releases tremendous amount of energy. And if we do the calculation using the Einstein formula, energy mass relation formula, the suns can shine for about 10 billion years. The sun continues to shine steadily still today because it has achieved two kinds of balance that keep its size and energy output stable. So the two kinds of stable balance are the gravitational equilibrium and the other is energy balance equilibrium. The gravitational equilibrium in the sun works more likely the same way as an acrobat stacks in a gravitational equilibrium. For example, if you look at this picture, this tells you the story of the gravitational equilibrium and the pressure. The lowest person here supports the most weight and feels the greatest pressure, and the overlying weight and the underlying pressure decreases as we go higher up. Now, if you look the weight, if you look the sun or any object, even the earth, the pressure increases with the depth. What does that mean? It means as you go deep and deep into the earth's surface, the pressure is higher. So the same thing here. This one supports most of the weight. The pressure here is much higher. So the energy released by fusion hits the gas and maintain that pressure and keeps the sun in balance against the inward pull of gravity. So the way and the sun the balances is due to the pressure. The, the pressure is outward and the gravity is inward. So they must balance each other. Let me tell you here in this graph here. So this tells you the story of the gravitational equilibrium. And all of you know that now. The energy and the sun is due to the nuclear fusion. So the energy supplied by nuclear fusion maintains that pressure. And why do we need that kind of pressure? Because the gravity tries to bring it inward. So the gravity tries to bring it inward and the pressure is due to the outward. So they must balance at some point to keep it in equilibrium. So the gravitational, this is what we call the gravitational equilibrium. So the gravity is towards the inward and the pressure which comes due to the nuclear fusion as it is releasing the energy must balance. And if you go deep and deep, the gravity is higher and higher. So is the pressure. So at any point, if I take any point the the gravity and the pressure exactly balance each other, and this kind of equilibrium we call as the gravitational equilibrium. And in the present case, the sun has achieved the gravitational equilibrium, and that's why it is stable. And another equilibrium that we're going to talk about is the energy, the balance. So what is the energy balance? We know that the sun is radiating energy. So the rate at which the sun radiates the energy is exactly equal to the rate of formation of energy by the nuclear fusion process in the core. So if you look, the when the during the nuclear fusion process, at which the nuclear fusion process occurs within the sun, or the rate at which the sun releases energy or forms the energy, it must be exactly equal to the rate at which the sun's radiated energy in the form of all electromagnetic radiation. So this kind of balance we call the energy, the balance. So the sun has achieved the two kinds of balance. The one is the gravitational equilibrium or gravitational balance, and the other is the energy, the balance. The energy balance is simply the rate at which the energy radiates from the sun must be the same at which it is released by the fusion process. Here are some of the properties of the sun. The radius of the sun is about 7 times 10 to the 8 meter, which is about 109 times larger than the earth. Okay, so the sun is about 109 times larger in diameter than the earth. The mass of the sun is 2 times 10 to the 30 kilogram, which is about 300,000 times larger or heavier than the earth. The luminosity, which we simply call the power, is about 4 times 10 to the 26 watt. So even if you just look at the power, it is huge power. It can supply the energy to the trillions of cities with this amount of the power. And as we go along, then I'll explain about this one. This is a huge power. Now let's talk about the temperature of the sun. Mostly in this class we'll be only talking about the two temperature of the sun. The one is the core and the other is the surface, the photosphere. So here the photosphere is this sun's surface. The temperature of this photosphere is about 6,000. So 6,000 Kelvin. And in the core, the temperature is much higher, and it can reach up to 16 million Kelvin. So the temperature in the sun core is about 16 million Kelvin, and at the surface it is about 6,000 Kelvin. Again, you can see that the interior of the sun and the different zone has a different the temperature. In this slide it gives you some of the other properties of the sun. As you talked about the radius, the sun is about 109 times larger. The sun is about 109 times larger in diameter than the sun. The mass of the sun is about 300,000 times larger than the earth. The luminosity, which we'll talk later, is simply the total amount of energy that is radiated from the sun, and it is about 10 to the 26 watt. What the sun is made of. This is not only for the sun. Remember, this is not only for the sun. The composition. As I talked, the sun, the source of the sun energy comes from the nuclear fusion, and the nuclear fusion is the combination, like when the two smaller low atomic numbered nuclei combine together to form a bigger nuclei, then that process is called the nuclear fusion. And it does happen in most of the stars. So the star does carry about 70% hydrogen and the 28% helium, and it does have the 2% heavier elements. So about 3/4 of the sun composition is hydrogen, 1/4 is about the helium, and the 2% is about the heavier elements. The temperature, the surface temperature of the sun is about 5800 Kelvin, and you might see some sun spots which is about 4000 Kelvin. The core temperature, the inner, so these are the sun spots. So the temperature of the sun spot is 4000 Kelvin, and the core is about 15 million Kelvin. So what you learned so far is the chemical and the gravitational energy sources are not enough to explain how does the sun generates energy. It was the Einstein's formula, the nuclear fusion E equals to mc square, by which we can explain it's the due to the nuclear fusion the sun shines. And if you do the calculation, then it can support by the Einstein calculation, it can support the energy for about 10 billion years. But the gravitational contraction, with the gravitational contraction, it can support only about 25 million years. So chemical and gravitational energy are not the means by which the sun generates energy. It is by the nuclear fusion process. And there are two types of equilibrium: gravitational equilibrium and the energy balance. In order to be in the stable condition which the sun is in today, both has to be made. The sun is, and the current present condition is in both in gravitational equilibrium and is in the energy balance. And in the next lecture, I'm going to talk about the luminosity, the brightness, and the magnitude of the magnitude, the absolute magnitude. Okay. And if you have any question, do not hesitate to contact me. And these all slides are very, very helpful for you to do your homework. Thank you so much.